Hi everyone. Today we're going to find discontinuities and end behavior asymptotes. So hopefully you're on the page in your packet where you can find this example so you can follow along with me. Also, I'm hoping that you've already watched the end behavior asymptotes video because you're going to want to refer to those rules while we're doing this specific problem. So it's really great to get your function into factored form if you can. So you've done a lot of practicing with factoring. So I'm just going to factor this one really quickly. G of x is going to equal x minus 3 times x plus 2 over x plus 2. Okay? Now, if you can recall from your last unit, when you look at that x plus 2 in the top here and the bottom, you would say to your teacher and to your friends, oh, those x plus 2's, that's going to be able to cancel from the top and from the bottom. And you're absolutely correct. You also got experience with saying, in this type of situation, that x cannot equal negative 2. We talked about that in the last chapter as well as in graphing in this unit. So x can't equal negative 2 because if you were to plug in negative 2, and you can look at that over here in your original example, if you were to plug in negative 2, it would cause your denominator to be 0. Okay? So what's happening here in this case is that because you can cancel this factor from the top and from the bottom, that's going to cause a hole. Okay? So now what's happened here is that you are left with y equals x minus 3. This is the function that you now have after canceling out that hole. So the x value of the hole is negative 2, and if I want the y value of the hole, I just plug back into the function. You're going to plug into the new one, the one after you've canceled out your hole. So negative 2 minus 3 is negative 5. Okay? Now, in this case, looking at y equals x minus 3, looking at this function here, if you were to graph that, that's just a line. So if I were to make a quick sketch, this is just a line with a hole in it. So in this case, there are no vertical asymptotes and no horizontal asymptotes. And no end behavior asymptote. Now, if I were to ask you for the domain of this function, you would tell me that the domain is everything except for negative 2, right? You told me right from the beginning that negative 2 is not a possible x value because it causes your denominator to be 0. Okay? Be careful, in your other examples, you are going to have to find vertical asymptotes and end behavior asymptotes. You have a video for end behavior asymptotes, and vertical asymptotes were discussed in the inverse variation video as well. Okay, everybody? Good luck.